Good morning, everyone. I am Teacher Kim, and welcome to another day of Maritime English, Week 41, Day 2. Before we move on to our next lesson, let's have a short recap of what we learned last Monday about marine engine failure drill. Drills are very important because they prepare the crew for real emergencies. They help us act quickly, correctly, and safely when problems happen in the engine room. We must always remember safety first. Always wear your personal protective equipment and follow all safety procedures. When something goes wrong, report clearly in simple English so everyone can understand. Clear communication can save time and even save lives. During the drill, always follow the six important steps: recognize, report it, take action, start safely, record the drill, and review the results. And lastly, remember our key message: be ready, be safe, because practice makes perfect at sea. We begin a new lesson on one of the most important systems in the ship navigation: the steering gear. This system is vital because it controls the ship's direction. When it fails, it can lead to serious accidents such as collisions or groundings. Our theme is steer safe, prevent failure. By the end of the lesson, you'll understand how the steering gear works, its components, and how to communicate effectively during steering related emergencies. So before we begin, here's our lesson agenda for today. First, we'll start with an introduction where we'll familiarize ourselves with the steering gear and its importance in keeping the ship on course. Next, we'll move on to the operation of steering gear system to understand how it works, for the rudder to the hydraulic and control mechanisms that steer the vessel. And then we'll discuss the common causes of steering gear failure, identifying what usually goes wrong and how these problems can arise on board. After that, we'll explore the effects and consequences of failure to understand how serious steering malfunction can impact ship safety, navigation, and crew operations. In fifth, troubleshooting and corrective actions. We'll go over practical ways to detect, diagnose, and fix problems efficiently. Next, we'll cover emergency procedures and drills, focusing on the correct responses and communication during an actual steering failure at sea. And finally, we'll end with a summary and conclusion, reviewing key points and reinforcing how proper knowledge and teamwork can prevent accidents and save lives. So get ready to learn and strengthen your maritime English skills as we go through each part of this vital lesson together. Introduction. The purpose is to be familiarized with the function of the steering gear and its crucial role in ship navigation and safety. Lesson objective. In this topic, we will learn not just about the mechanical system, but also how to use corrective English terms like rudder, hydraulic pump, and helm. Understanding these words helps you communicate clearly with the bridge team and the engineerings during operations or emergencies. Importance of steering gear in navigation. The steering gear is what allows to control the ship's direction by moving the rudder. Without it, we can't navigate properly. It's especially important when passing through narrow channels, entering ports, or avoiding danger. If it fails, the ship loses control, collide, or even run aground. That's why keeping it in good condition is essential for safe navigation. Now, let's go on to the main components and function. First, we have rudder, the flat surface at a stern that changes the ship's direction when turned. As you can see in this picture, this is the rudder. Next, the hydraulic pump provides pressure to move the rudder through hydraulic oil. Third, we have the motor. Drives the hydraulic pump can be electric or powered by an engine. Last is the linkages and rams. Connect the rudder stock to the steering gear, transmitting force. These components work together to turn the ship's rudder. The motor powers the hydraulic pump, which pushes oil through pipes to move the rams and turn the rudder. It's a teamwork of machinery. Each part plays a vital role in steering. So, what are the main types of steering gear? First, we have mechanical steering gear. It is a simple system using chains, rods, or cables directly connected to the helm. It is commonly used in small boats and older or smaller vessels, or sometimes a backup or emergency system on larger ships. Next is the hydraulic. Uses pressurized oil and pumps to move the rudder. It is common on a wide range of vessels, including larger power boats, yachts, and other smaller commercial ships. Last is the electrohydraulic, a combination of electric control and hydraulic power. Offers high efficiency and reliability. It is widely used on larger vessels due to the immense force required to move the rudders. Different ships use different types of steering gear. Most larger vessels today use the hydraulic or electro-hydraulic systems, which combine electric control with hydraulic movement. This allows smoother and faster response. perfect for modern ships. Next is steering gear's role in ship control. Controls rudder movement for precise navigation, maintains course stability with autopilot, responds instantly to helm orders, essential for collision avoidance and maneuvering in restricted waters, and ensures safety of navigation and cruise confidence during voyage. So when you heard the command port 10 or starboard 5, the steering gear responses immediately. It translates the helm's order into action or into motion, moving the ship safely. And remember, good steering means smooth navigation and safety for everyone on board. So let's have our first vocabulary English practice. First is the rudder. It is a movable plate at the stern that changes ship direction. For example, the rudder moves to port. Next is helm, the wheel or lever used to steer the ship. For example, operate the helm smoothly. Next is the hydraulic cylinder, device that uses oil pressure to move mechanical parts. For example, check the hydraulic cylinder for leaks. And lastly, autopilot, system that automatically maintains a set course. Sample, switch to autopilot mode. Remember, clear communication in English is very important during steering operations. Simple, correct words prevent misunderstanding, especially between the bridge and the engine room. Now that we are finished to the introduction, let us move to the operation of steering gear system. Here I'll explain how the steering gear operates and responds to bridge commands through electrical, hydraulic, and mechanical system. So how steering gear works? So as you can see in this diagram shows the flow of signals in the steering system from the bridge all the way to the rudder. It starts at the bridge, where the helmsman or autopilot sends a steering command. The signal goes to the control unit, which interprets the command and activates the hydraulic pump. The pump produces the hydraulic pressure needed to move the rudder, which changes the ship's direction. In simple terms, it's like a chain reaction. The order starts at the bridge, passes through the control system, powers the hydraulics, and finally moves the rudder. Each step is vital, and if one part fails, the entire steering function can be affected. Order transmission from bridge to rudder. Bridge command. The helm turns the wheel or the helm or autopilot sends a signal. Next is the signal transmission. An electric signal travels from the bridge control unit to the steering gear control valve. Actuation. The control of the valve directs hydraulic oil flow. Next is the rudder movement. And lastly, feedback. You can also see at this flow the sample order transmission from bridge to rudder. To make it simple, as you can see in the picture, from bridge gives command, goes on to control unit, gives signal that will put hydraulic pump into motion that will move the rudder. So that is the order transmission from bridge to rudder. Next is the electrical and hydraulic control units. It acts like a brain, sending orders. Electric control unit, located on the bridge and steering gear room, sends commands to control the direction of a hydraulic valves, can operate in manual, non-follow-up, or autopilot mode. Again, it acts like the brain. Next is the hydraulic control unit. Now, this acts like the muscle. It contains pumps, valves, and actuators, uses pressurized hydraulic oil to move rams and tillers, and equipped with relief valves and reservoirs to maintain pressure and safety. They must work together perfectly. Any delay or error between these systems can cause steering problems or even accidents. Remember, the electrical unit acts like the brain, sending orders, and the hydraulic unit acts like the muscle, moving the rudder. Feedback mechanism explained. So how it works. First, the angle sensor detects rudder position. Next, signal sends back to bridge control unit. Third, control unit compares actual position with order position. And fourth, and different system adjusts hydraulics until they match. It means that feedback mechanism ensures the rudder's position matches the helm order. The purpose is to prevent oversteering and maintains accuracy. The feedback system is what keeps the ship on correct course. Think of it as like a teacher correcting your steering. It checks if the rudder is in the right position and adjusts automatically. Without feedback, the ship could easily overturn or steer off course. So that is feedback mechanism explained. Next is the manual versus automatic operation. So what are the difference between the two? First is the manual operation. The helmsman controls the rudder directly through the helm or NFU. Example, when the autopilot is off, during maneuvering or port approach. Next is the automatic operation. It is an autopilot system maintains a set course by adjusting the rudder automatically. Example of use for this is during open sea navigation. Always ready to switch to manual if automatic fails. And NFU or non-follow-up mode always direct rudder control from steering gear room in emergencies. Ships today often use autopilot during long voyage, but the crew must always be ready to take manual control if needed. Manual steering is critical during berthing, heavy weather, or steering gear malfunction. Seafarers must know how to shift between these modes smoothly. So that is the difference between manual and automatic operations. Safety lock systems and emergency control. First is prevent accidental movement or the rudder wheel maintenance is done. Includes hydraulic isolation valves and rudder locking pins, allows steering directly from the steering gear room when bridge control fails, manual operation through local control levers or hand pumps, and backup hydraulic pumps and power units for redundancy. In the case the bridge control fails, the ship can be steered from the steering gear room. This is called emergency control. You can use a hand lever, backup pump, or manual valves to move the rudder. Remember, safety locks are used during maintenance to prevent accidental motion. Always engage them when before entering the area. And an important note, SOLAS or safety of life at sea requires two independent steering systems for safety. Next is the three major parts: the telemotor, control unit, and power units. That is the three major parts of steering gear system. First is telemotor. It sends steering commands from the bridge to the steering gear using hydraulic or electrical signals. Next is the control unit. It processes the signal and ensures the rudder moves to the correct angle through a feedback system. And lastly, the power unit. It provides the force to move the rudder using hydraulic or electrohydraulic power. Always maintain cleanliness, check for leaks, and make sure communication with bridge is working. So that is the three major parts of steering gear system. Now let's proceed to our second vocabulary English practice. First we have helm order. It is a instruction rather from the bridge to change direction. For example, execute helm order to port 10. Next is feedback unit. means device that measures rudder position. For example, check the feedback unit for proper signal. Next, we have control valve, regulates hydraulic oil flow to move the rudder. For example, control valve directs the oil pressure. And lastly, emergency steering, manual control when normal system fails. For example, report steering gear condition to the bridge. Remember, good communication is vital in steering operation. Simple English phrases like report steering gear condition to the bridge can prevent confusion and delay. Clear, calm, and simple English reporting keeps the team synchronized during emergencies. Now that we've learned about the operation of the steering gear system, now let's proceed to the common causes of steering gear failure. Identifying what usually goes wrong and how these problems can arise on board will identify technical and human causes of steering failure as well. So the causes of steering gear failure can be electrical and hydraulic fault, pump or motor malfunction or low pressure, mechanical linkage or valve blockage, human error and poor maintenance, overheating or incorrect operation, importance of regular inspection. Now that we understand how steering gear operates, let's focus on what can go wrong. Steering gear failure can happen anytime, and what it does, the ship loses control. Knowing the causes help us prevent accidents before they occur. Remember, in maritime safety, prevention is always better than reaction. Electrical and hydraulic faults, power loss, leaks. So common electrical faults, power supply failure from the main or emergency switchboard, blown fuses or chipped circuit breakers, loose wiring or coordinated terminals, faulty control relays or sensors. And some of the common hydraulic faults is oil leaks from pipelines, joints, or seals, air in the hydraulic system causing jerky movement, low hydraulic pressure or contaminated oil, and overheating of pumps on valves. So electrical and hydraulic faults are the most common causes of steering failure. A simple oil leak or loose electrical wire can disable the entire system. So regular testing or emergency power and checking for leaks are essential to keep the steering gear reliable. Now, next is the pump or motor malfunction or flow oil pressure. So, pump malfunction can fail or failure of electric motor or coupling, worn out pump parts such as pistons and seals, and vibration leading to misalignment. And the low oil pressure caused by leaks, clogged filters, or faulty relief valves and results in slow rudder response or no movement at all. The effects of this can delay the rudder reaction, inability to maintain course, and increase steering efforts and risk of collision. Remember, the hydraulic pump is like the heart of the steering gear. It pushes the oil that moves the rudder. If it fails or loses pressure, the rudder won't respond. That's why daily checks on pressure gauges, oil levels, and filter cleanliness is vital. Mechanical linkage or valve blockage. Mechanical problems, broken or loose linkages between rams and tiller, bent rods or worn out bearings, and damaged rudder stock connection. And for the valve blockage, dirt or sludged in hydraulic oil blocking valve movement, corrosion inside valve housing, and improper lubrication causing stiffness. This can result the rudder may stick at one position or move slowly. Also, inconsistent response to helm orders. When mechanical parts jam or valves get blocked, the rudder may refuse to move or respond slowly. It's like trying to turn a wheel stuck in a mud. So it needs cleaning, lubrication, and proper maintenance to work smoothly. Now let's discuss the human error and poor maintenance. For human errors, wrong operation of steering control, failure to switch to standby pump during drills, delay in reporting unusual sounds, vibrations, or leaks, and last is neglecting to test emergency steering. For the poor maintenance, we have irregular oil change or filter cleaning, ignoring small leaks or pressure drops, and no proper record of instructions. Did you know that around 30 to 40% of steering failures are due to human negligence or improper maintenance? Even with the best equipment, human error can cause failure. Forgetting to test pumps, ignoring alarms, or skipping maintenance may lead to disaster. Every seafarer must start or stay alert, report immediately, and follow maintenance schedule strictly to avoid human error and poor maintenance. Now let's discuss overheating or incorrect operation. For overheating causes continuous use of a single pump without rest, blocked cooling lines, and contaminated hydraulic oil increasing friction. And for incorrect operation, we have repeated rapid helm orders without pause, operating with insufficient oil, and failure to follow correct startup procedures. The consequences is for this is damages the seals and valves. Also oil, oxidation, and pressure loss. And lastly, sudden steering system shutdown. Overheating happens silently but can cause serious damage. When the oil becomes too hot, it loses viscosity, and the system's power weakens. So always operate the helm smoothly, avoid overuse, and ensure both pumps share the overwork or the overload. Next, importance of regular inspection. So why regular check matter? Because it detects early signs of failure before they become critical, ensures compliance with SOLAS and company safety policies, keeps crew familiar with emergency steering operation, and builds confidence in ship handling. So what is the inspection routine? Check oil level and cleanliness, inspect for leaks, loose bolts, or abnormal vibration, test both main and standby pumps, and lastly, verify bridge steering room communication. Because regular inspection is the best defense against steering failure. Before every departure, the officer of watch and the engineer must test the system. During drills, everyone should practice shifting to emergency steering. Inspection means prevention. So now let's go on to the our vocabulary number 3, English practice. We have linkage, malfunction, breakdown, and overheat. First, linkage. Unwanted escape of fluid from the system. So for example, report any leakage immediately. Next is malfunction. Failure of a system to work properly. Sample sentence is the steering pump malfunction during operation. Next is breakdown. It is a complete failure of equipment. Sample sentence for this is the vessel experiences steering gear breakdown. And lastly, overheat, to become excessively hot. For example, the pump overheated due to continuous operation. Again, communication during steering gear problems must be short and clear. Always use simple English. For example, steering gear malfunction or oil leak in pump room, so that every crew member understands quickly. In an emergency, clear language saves time and lives. Now that we know all the common causes of steering gear failure, now let's proceed to the effects and consequences of failure. The purpose is to show how steering gear failure affects ship safety, navigation, and operations, and emphasizes the importance of communication and quick response during emergencies. Effects of steering gear failure. We have lost control or unable to maintain course, risk of collision or grounding, delay and voyage disruption, emergency maneuvers and rudder stress, and communication with bridge team. Every system board is important, but few are as critical as the steering gear. When it fails, the ship can lose direction, control, and safety. In this topic, we'll see what happens when steering gear fails for loss of control or real accidents, and how quick response and good communication can prevent disasters. First is the lost control and unable to maintain course. So the immediate effects is the rudder stops responding to helm orders, the ship begins to drift or turn unintentionally, and lastly, the autopilot alarm or steering alarm activates. For operational impact, the helmsman loses control over ship's heading, difficulty in maintaining a safe course in traffic or narrow channels, and increased stress for bridge team. When steering fails, the first sign is often the rudder doesn't respond. You might hear an alarm or see the ship starts turning without command. In such a situation, immediate communication between the bridge and engine room is vital to regain control or shift to emergency steering. Next would be the risk of collision or grounding. So collision risks. Ship cannot maneuver to avoid obstacle or other vessels, increased damage during congested waterways or port approaches, and difficulty in responding to traffic signals or pilot instructions. So what are the grounding risks? Ship drifts toward shallow water or shore, damage to hull, rudder, or propeller, and possible oil spill or pollution incident. So when steering fails, even a few seconds can make a difference. Imagine being in a narrow channel. Without steering, the ship can hit another vessel or run aground. Many real-life accidents happen because crew couldn't act or communicate fast enough. So that is the risk collision or grounding. Next, delay and voyage disruption. So the operational consequences is ship must stop or reduce speed to repair steering gear, delay in cargo delivery schedules, possible detention by port authorities for inspection, increased fuel consumption if detour is required. For economical effects, we have financial loss to shipping company and charterers, repair costs and insurance claims, and reputation damage and loss of client trust. Even if no collision happens, a steering failure still causes major voyage delays and financial loss. Every hour of downtime costs money. For this reason, keeping the steering gear in top condition is not only about safety, it's also about operational efficiency. Next is emergency maneuvers and rudder stress. The emergency maneuvers use of twin engines or thrusters to change direction, shifting to emergency steering from steering gear room, and dropping anchor to stop drift in shallow areas. The rudder and system stressed. The sudden pressure changes the hydraulics, excessive load or rudder stopped and bearings, and risk of hydraulic oil overheating or seal damage. During a failure, the crew may perform emergency maneuvers using engines or thrusters to steer temporarily. But these actions create extra stress on the rudder and hydraulic system as well. That's why all action must be coordinated and careful to avoid worsening the damage. And last is the communication with the bridge team. Importance of clear communication. Report immediately. Steering failure, no response to help. Next, bridge should acknowledge and switch to manual or emergency mode. And lastly, continuous update between bridge, engine control room, and steering gear room. So here are the standard phrases that we can encounter. No response from steering gear, switching to standby pump, changing to emergency steering control, and report rudder angle position. In any failure, clear and quick communication is the key. The bridge must immediately know the status of the steering gear so captain can react. Avoid long explanation during emergencies. Now let's proceed to our vocabulary number 4, practice English. We have collision, grounding, rudder angle, and voyage delay. So collision, when two ships or objects strike each other. Sample sentence for this is the vessel collided with a tugboat after losing steer. Next is grounding, when a ship touches the seabed or shore. Sample for this is grounding occurred due to steering failure. Next is rudder angle, the degree to which the rudder is turned from the center line. Sample for this is report the rudder angle to the bridge. Lastly, voyage delay, a setback in scheduled travel time due to mechanical issues. Example for this is steering failure caused a 12-hour delay. Now that we already discussed the effects and consequences of failure, now let's proceed to the troubleshooting and corrective actions. The purpose of this is to learn how to systematically identify, analyze, and correct steering gear problems while maintaining proper communication with the bridge and engine room. Troubleshooting gear. Steering gear failure requires quick thinking, helps, and systematic troubleshooting helps prevent accidents. So when the steering gear fails, quick thinking, systematic troubleshooting can prevent an accident. So first take action, plus identify the problem will result to troubleshooting. Troubleshooting means identifying what went wrong and taking corrective steps to restore steering control. So let's discuss or let's learn how to do the step by step. First is identify the problem, alarm, pressure, or movement. First is observe alarms and indicators. In this, we check for steering failure alarm on bridge and steering gear room. Step 2 is to monitor pressure gauges. Normal system pressure is a sign of healthy hydraulic flow, and low pressure may indicate leakage or pump failure. Lastly is check rudder movement. It confirms if the rudder moves when helm is operated. The first step is identification. Listen for alarms, observe warning lights, and check rudder angle indicators. If the rudder isn't moving or the pressure drops, you have a problem. Always stay calm and follow procedures. Now check electrical system. First step is inspect control power supply and fuses. Second, verify if control signals from bridge reach the steering control unit. Third step is check switchboard for tripped breakers or loose connections. And lastly, if there's no power, report immediately to the bridge. For example, a sudden blackout in the steering system could be to a blown fuse or critical breaker trip. So electrical results a common cause of steering problems. A tripped circuit or short circuit can stop power from reaching the steering gear motor. So always wear your PPE before checking electrical panels and never touch live circuits. Next is check hydraulic and oil leaks. First step is inspect hydraulic oil level in the reservoir. Second is look for oil leaks in pipes, joints, and cylinders. Step 3 is check oil temperature and pressure. And step 4 is refill or change oil if necessary with proper oil type. The key point is hydraulic oil loss is equals to loss of power to move the rudder. If you see an oil around the deck or under the pump, it's a sign of a leak. Low oil levels will cause loss of pressure. The rudder won't move properly. Always isolate the leak, clean up, and report to the bridge. Next is to shift to standby pump or switch to manual mode. For standby mode operation, start the second hydraulic pump if the first one fails. Next is to confirm the pressure returns to normal. For manual mode, engage normal control in the steering gear room when automatic mode fails. And operate the tiller manually if necessary. For example, in emergency conditions, steering may be controlled locally from the steering gear compartment. If the main system fails, activate the standby pump. If still no response, switch to manual control from the steering room gear. Always inform the bridge before making this change. Next is report to bridge and record findings. First is bridge communication protocol. Bridge steering failure, switch to standby mode, to standby pump rather. Bridge manual steering in progress. For record in the engine room logbook, we have nature of failure, take action, action taken, and time restored. Communication is the key. The officer on watch must keep the bridge informed every step of the way. After solving the problem, document the incident clearly. It helps in future maintenance and safety audits. So, what are the tools and safety equipments? First is essential tools and safety equipment. Troubleshooting is not only about fixing system, it's also about protecting yourself. So proper tools and PPE keep you safe while working around the high pressure hydraulic system. And a safety reminder, always isolate electrical power and the hydraulic pressure before touching machinery. Coordination with engine room. Independent systems. See steering and engine system work together. to ensure safe maneuvering of the vessel. A failure in one system can affect the performance of the other. Engine room team support. We have power supply checks, ensures that electrical and hydraulic power is available for steering gear operation. Assistant with pumps and valves. It operates standby pumps, open or close valves, and provide hydraulic support when required. And support during emergency steering operations. Helps maintain rudder operation or control during failures or emergency situation by providing mechanical or hydraulic assistance. And lastly, always maintain radio or intercom contact. Always maintain continuous contact with the bridge via radio or intercom to coordinate actions and report status promptly. The bridge, steering gear room, and the engine room must act as one team. During a steering emergency, teamwork and clear communication can save the ships from danger. Now, this is the troubleshooting flowchart. First is alarm or rudder not moving, means the first indicator of a steering gear issue is usually an alarm or the rudder not responding to the helm's command. So stop and assess the situation calmly to avoid sudden maneuvers. Next is the check power supply. Verify the steering gear has electrical or hydraulic power. Inspect circuit breakers, fuses, and main switches for proper operation. Next is check hydraulic oil level. Low hydraulic oil can prevent the steering gear from moving. Look for leaks, check reservoir levers, and ensure oil is clean at the correct pressure. Fourth, start standby pump and switch to normal. If the main system fails, engage the standby pump or switch to manual mode. This provides temporary control of the rudder while troubleshooting continues. And lastly, report and record. Immediate information or immediately inform the bridge of actions to take the current steering status and record all observations, alarms, and corrective pressures for documentation and future reference. The purpose of this flowchart is to provide a step-by-step guide to quickly diagnose and correct steering gear issues and ensure safety, coordination, and proper communication during emergencies. Let's proceed to our vocabulary number 5, English practice. We have troubleshoot, pressure gauge, leakage, standby pump, manual control. Troubleshoot, fix a problem. Pressure gauge, when the ship touches the seabed or shore. Leakage, escaping fluid from a pipe or joint. Standby pump is backup pump used when the main oil fails. Manual control is operating system by hand instead of automatic mode. Learn and practice key steering gear terms for clear communication in emergencies. Now that we've known about the troubleshooting and corrective actions, now let's proceed to the emergency procedures and drills. The purpose is to reinforce emergency preparedness, proper steering operation in case of failure, and effective English communication between bridge and engine steering team. First is emergency risk procedures, steering gear failure, quick action saves time and prevents accident. Emergency procedures operate backup systems, follow proper chain of command, and maintain clear communication with the bridge. In a steering gear failure, knowing the emergency procedure saves time and prevents accident. Emergency procedures include operating backup system, following proper chain of command, and clear communication with the bridge. Today we will go through these steps in detail. Importance of drills and crew preparedness. Drills are like rehearsals for a real accident. So practicing emergency steering regularly ensures everyone knows their role and reacts calmly. This is crucial because emergency happen without warning. Drills prepare the crew for real emergency without risks. Familiarity with emergency controls ensures quick response and builds confidence and teamwork among bridge, engine room, and steering gear personnel. Emergency steering operation, steering flat or hand pump. Steering flat method, rather controlled locally from steering gear room using levers. And pump and hand pump operation is a manual hydraulic pump used when electric pumps fail. The steps for this is first isolate main hydraulic tower, second is engage emergency manual steering, and third operate hand pump or lever to move rudder. In case the main steering fails, the crew uses emergency steering. You can operate the rudder manually with a lever or hand pump. Through slower, it ensures the ship can still maneuver safely. Next is the bridge communication, sound-powered phone. Sound-powered phone is a primary emergency communication tool used when power supply is lost for normal radios or intercoms. Messages should be clear, short, and precise. For example, bridge to steering, rudder port 10 degree. Another example is switching to emergency steering mode. During emergencies, the sound power phone ensures that the bridge and steering room remains in constant contact. Unlike radios, it works without electricity, which is critical if power fails. Next, chain of command and crew roles. So first we have the captain. It, it's the overall command, decision making, and coordination. The bridge team. It monitors it monitors course, issues helm orders, communicates with engine and steering room. Engine and steering room team executes manual and emergency steering, monitors hydraulic system. All crew members support drills, report issues, assist in backup operation. So during a steering failure, everyone has a defined role. The captain decides, the bridge communicates, and the engine or steering team executes. Knowing your role ensures no confusion and faster response. Next is drill frequency and objectives. Frequency. Monthly emergency steering drill recommended by SOLAS. Ad hoc drills during special voyage or after maintenance. The objective is familiarize crew with emergency steering, practice bridge to steering communication, and test readiness and backup system in manual pump or standby pump. Regular drills maintain crew readiness. Even experienced officers can forget procedures if not practiced. So drills should cover all types of failure, including complete power loss. So here are some of the reporting phrases or standard emergency phrases we can encounter. Port 10 degrees, starboard 15 degrees, switching to emergency mode, and rudder movement confirmed, angle 5 degrees. Using short, clear phrases reduces confusion during critical moments. Practice these phrases until they become second nature. And now let's proceed to our vocabulary number 6. We have emergency steering and sound powered phone. So emergency steering is a backup rudder control method when normal system fails. An example sentence for this is engage emergency steering immediately. Next is sound powered phone, communication device working without electricity. Example, report rudder angle using the sound power phone. These terms are key for communication in emergencies. Knowing them ensures you can act quickly and correctly. Now that we've tackled emergency procedure drills, let's move on to the preventive maintenance and inspection. The purpose of this is to emphasize the importance of prevention maintenance. Regular inspections and proper recording avoid steering gear failure and ensures safe navigation. Preventive maintenance. It prevents steering gear failure. Regular check keeps equipment in good condition. Record keeping helps track maintenance history and follow procedures to ensure safe and efficient ship operation. Constant prevention maintenance, regular checks, proper recording, and adherence to procedures ensures reliable steering gear operation and overall ship safety. For regular oil and pressure check, we have oil level check, ensures hydraulic oil is at recommended level before each voyage. Oil quality. Inspect for contamination, discoloration, or debris. Pressure checks. Verify main and standby pump pressure with gauges. Frequency. Daily checks during operations, especially before departure. Hydraulic oil is the lifeblood of the steering gear. Low levels or dirty oil can cause pump failures or slow rudder response. Always check pressure gauges and maintain oil at the correct level. Inspect hydraulic lines, seals, filters, and valves. Hydraulic lines. Check for leaks, cracks, or erosion. Seals. Ensure seals are intact to prevent oil leakage. Filters. Clean or replace to avoid blockage and maintain oil flow, and valves is inspect for proper movement and no obstruction. Leakage or blockage in hydraulic lines or valves reduce system's efficiency and may lead to failure. Inspection ensures that every component works properly before sealing. Let's move on to lubrication and electric tightness. So we have lubrication, electric connection, and avoid over lubrication. Lubrication. Apply grease to moving parts. Rather, stop linkages and bearings. Electrical connections. Check tightness of wires, terminals, and relays. And last is avoid over lubrication. Prevent accumulation of dirt and contamination. Mechanical gear, mechanical wear, and loose electrical connections are common causes of steering failure. Lubrication keeps parts moving smoothly, while tight electrical connection ensures reliable power and control signals. Steering gear test before departure. Pre-sailing test steps. First is start main and standby pumps. Second is move rudder to port and starboard fully. Third step is confirm proper rudder angle response at bridge indicators. And lastly, test alarms and emergency steering if possible. The purpose of this is to detect any malfunction before leaving port. Before every voyage, the steering gear must be tested. Moving the rudder fully to port and starboard board ensures pumps, linkages, and hydraulic systems are working. This is simple but critical step for safety. Record keeping and planned maintenance system or PMS. Daily log records oil levels, pressure readings, and any abnormalities. Plant maintenance system. Schedule routine inspections, repairs, problem replacement. The benefit of this is to prevent unnoticed faults, facilitates audits and safety inspection, and supports crew accountability. By maintaining detailed record ensures every check is documented. PMS allows planning of inspections and repairs so that no problem is overlooked. Accurate records also help the captain and chief engineer monitor steering gear condition. Now let's proceed to our vocabulary number 7. We have preventive maintenance, hydraulic lines, seal, and PMS, plant maintenance system. Preventive maintenance, routine checks and servicing to prevent failure. For example, perform preventive maintenance before departure. Hydraulic lines, pipes carrying oil in the steering system. For example, inspect all hydraulic lines for leaks. Seal, component preventing fuel leakage. For example, check seals for wear or damages. And lastly, PMS or plant maintenance system is a scheduled maintenance plan. For example, update PMS after completing steering gear check. Use simple and clear English when reporting inspections or maintenance. Clear communication helps keep the bridge and engine room informed. So that's the last lesson regarding preventive maintenance and inspection. Now that we've completed the lesson, let's take a moment to recap the key points. We'll go through the topics we've covered, review important terms, procedures, and best practices, and make sure everyone understands the essential aspects of steering gear operation, troubleshooting, and maintenance. This will help reinforce your knowledge and prepare you for real onboard situations. Steering gear is vital for ship maneuvering. It consists of components like rudder, hydraulic pump, motor, and leakages. Linkages. Systems can be mechanical, hydraulic, or electrohydraulic. Knowing basic ensures better control and situational awareness. For topic 2, operation of steering gear system. The steering gear responds to bridge commands through electrical or hydraulic controls with feedback mechanisms showing rudder position. Operation modes include manual and automatic, supported by safety devices like locks and emergency controls. Remember, understanding operation ensures correct response in both normal and emergency controls. Topic 3, common causes of steering gear failure. Failures may be caused by electrical or hydraulic faults, pumps or motor malfunctions, mechanical blockages, overheating, human error, or poor maintenance. Regular inspection helps prevent these issues. Remember, proactive maintenance and proper operation prevents steering failures. For topic 4, effects and consequences of failure. A steering gear failure can lead to loss of control, collisions, grounding, and voyage delays. Emergency maneuvers put extra stress on the rudder, making communication with the bridge crucial. Remember, steering failures impact safety, schedules, and coordination. Immediate action and reporting are essential. Troubleshooting and corrective actions. Systematic troubleshooting involves identifying problems, checking through alarms, pressure readings, or rudder movement, checking electrical and hydraulic systems, and switching to standby pumps or manual control is necessary. After report and record findings. Remember, teamwork, systematic troubleshooting, and proper reporting restores steering safely. Topic 6, emergency procedures and drills. Emergency procedures involve using steering flats or hand pumps, communicating with the bridge via sound-powered phone, and following with defined chain of command. Regular drills ensure the crew is ready for emergencies. And remember, preparedness, drills, and clear communication prevent accidents during steering failures. And lastly, topic 7 is preventive maintenance inspection. It is a foundation of reliable steering gear. Regular checks of oil, pressure, filters, seals, valves, and electrical systems, along with proper lubrication and departure tests, keep the system in optimal condition. Record all inspections in the PMS or logbook. Remember, consistent maintenance ensures safety navigation and reduces the risk of failure. In conclusion, steering gear knowledge ensures safe navigation. It is essential for ships to operate. Troubleshooting drills and maintenance prevents failure. Understanding components, operation, and failure causes allows quick and effective action. Teamwork and communication are essentials. So troubleshooting, emergency procedures, and drills ensures preparedness. Clear communication and teamwork are the key to safe and efficient navigation. Stay prepared, follow procedures, and maintain the steering gear to protect the vessel, crew, and cargo. To make sure we fully understand the key points, we'll do a short Q&A session. This will help review important concepts and reinforce our maritime English communication skills. I'll give you 5 seconds to each question and think before answering. Remember, this is not a test. It's a chance to practice, recall, and discuss what we've learned. So let's begin, and I encourage everyone. First question: what is the main function of a ship's steering gear? A. To supply power to the engines. B. To control the rudder and to maintain the ship's course. C. To monitor fuel consumption. Or D. To operate the anchor. If you answered B, to control the rudder and maintain the ship's course, and that is correct. Good job. Second question. Which of the following is not a type of steering gear? A. Mechanical. B. Hydraulic. C. Electrohydraulic. And D. Pneumatic. If you answer D. Pneumatic, and that is correct. Nice work. Question number 3. Which of these is a common cause of steering gear failure? A. Electric faults. B. Mechanical blockage. C. Human error. Or D. All of the above. If you answered D. All of the above, that's correct. Great job. Question number 4. During a steering gear failure, what is the first thing that crew should do? A. A. Start the engine at full speed. B. Identify the problem by checking alarms, pressure, and rudder movement. C. Notify the captain after the vessel hits the shore. And D. Perform maintenance without reporting. If you answered B, identify the problem by checking alarms, pressure, and rudder movement, that would be correct. Excellent. Question number 5. What is the purpose of emergency steering drills? A. To practice navigation in good weather. B. To familiarize the crew with emergency procedures and communication. C. To replace the main steering gear. Or D. To test the fuel efficiency. If you answered B, to familiarize the crew with emergency procedure and communication, then you are correct. Great job. Question number 6. Which tool or system is primarily used for bridge to steering communication during power loss? A. Walkie talkie. B. Email system. C. Sound powered phone. Or letter D. Loudspeaker. If you answered letter C, sound powered phone, then that's right. Great job. Lastly, question number 7. What is the key benefit of preventive maintenance for steering gear? A. Reduces voyage speed. B. Prevents steering failures and ensures safe navigation. C. Increases fuel consumption. Or D. Eliminates the need for crew training. If you answered B, prevent steering failures and ensure safe navigation, that would be correct. Great job. Steering gear is the ship's control heart. Safe steering depends on teamwork, training, and communication. Thank you everyone for today. We've completed our lesson on steering gear failure, covering the operation, common causes, emergency procedures, troubleshooting, and preventive maintenance. Remember, understanding the steering gear is not just knowing the machinery. It's all about ensuring the safety of the ship, crew, and cargo. Always follow proper procedures, communicate clearly, and perform regular checks to prevent failures. Keep this lesson in mind. Stay alert and always prioritize safety. I look forward to seeing you apply this knowledge in drills and in real life situations. Thank you.